Hi everyone, my name is David Perez and today I will explain the principles of Iridium for the subject telecommunications for air navigation. So, without any further review, let's get to it. As you might know, Iridium is a satellite-based communication network developed by Motorola. On the following video, I will explain how it is distributed, how it works, its uses in aviation and outside, terminals and prices, regulations, comparison with the competence, and of course, my personal opinion about it. In the description below, I will link the resources I have used to make this video, for if you want to have a look. And of course, if you have any doubt, feel free to leave a comment and I will do my best to try to answer all of them. As I said before, Iridium is a satellite-based communication network. It started working on the 1st of November of 1998. It comes with 66 satellites. In fact, the name Iridium comes from the number of satellites that were to be launched in the initial plans, being 77. This is the atomic number of the Iridium. In the end, just 66 satellites were launched. Talking about satellites, one of the most important factors that defines the operability of a satellite is the orbit. There are three main kinds of orbits: MEO, LEO, and GEO. LEO, or low Earth orbit satellites, are the ones that orbit relatively near to the Earth, having this way to orbit very fast and therefore being more propense to Doppler shuffling, having a shorter field of view, and that's why a fleet is needed for communication services. However, there are two advantages that none of the other orbits can have, that are less delay and a better signal strength due to their proximity. MEO, or medium Earth orbit, are working between 8,000 and 18,000 kilometers from the Earth. Therefore, they have a wider field of view, but having a lower strength of the signal and a higher time delay. GEO, or geostationary satellites, however, work in a very different way. They are at such a distance, about 35,000 kilometers from the Earth, that they rotate together with it. This means that the satellite is able to stay, from our point of view, stopped in the air. This also means that they are the 24 hours of the day looking at the same place, as well as covering about the 44% of the Earth on their field of view. This has a clear advantage, however, due to their high altitude, they suffer from huge delays and the transmitted signal is much weaker. Iridium works on 6 LEO orbits, with 11 satellites each, making a constellation of 66 satellites working at 780 kilometers from the Earth. The 6 orbits are equally spaced, having an 86-degree inclination with respect to the equator. Satellites of 2 nearby orbital planes are out of phase in order to minimize the overlay of the zones with each satellite's coverage. And so, they provide premium service for all the users, who can benefit from having global range, as well as not having to bring huge phones and providing quality of service with almost no lag. Satellite communication. The communication with the satellites is split in three parts. The ones that goes from the phone to the satellite, the inter-satellite links, and last but not least, the gangways. For the satellite to phone network, L-band was assigned. This goes from 1616 to 1626.5 MHz. The reason why this band was assigned to Iridium was that since the power of a mobile terminal is limited, the band that has the least atmospheric absorption was selected in order to have minor losses. The access technique used is FDMA-TDMA, which does not allow other operators to share the spectrum. However, this increases the reliability and allows terminals to be able to transmit in full duplex with a channel speed up to 50 kilobits per second. The antennas used for this purpose are the phased array multibeam. These antennas allow the use of different frequencies and different means, as you can see. Said this, the network divides the Earth on 37 cells, approximately of a diameter of 667 kilometers each. The Iridium system is the only one of the so-called big LEO. This means that intersatellite communications are used whenever a direct link with the ground station is not possible. The system is composed of an intelligent network of satellites that are able to redirect the traffic from one to another, creating the concept of a spatial network. For intersatellite purposes, the satellites have 4 antennas working in the Ka band that goes from 23.18 to 23.38 GHz. Iridium satellites are connected with two satellites in the same orbital plane and two satellites in the adjacent orbital planes. Gateways. These are Earth-based stations located in the surface of Earth. These are the ones in charge of connecting the Iridium satellite network with the public telephony lines. They are all based on GSM technology and they use 19.4 to 19.6 GHz Ka band for downlink and 29.1 to 29.3 GHz Ka band. So, handover. This is one of the main problems with satellite communication, at least in low Earth orbits. This is due to the fact that Iridium satellites travel at 7,400 meters per second, which in a around 700 kilometers cell make that a point on Earth is not in the same cell for over 100 seconds, and so the handover probability is more than possible. So, in order to minimize the probability that the call is lost in handover, some channels are left free for this purpose. These channels are not available to make new calls, but just to ensure handovers. We cannot forget also of the fact that handover is not just on the phone to satellite communication, but also in the inter-satellite communication, and the same problem happens on the gateways. So the system is quite complex, and sometimes it breaks down. The main competitors for Iridium are Inmarsat and MTSat, but since the last one is just available in Japan, it will not be covered in this video. So let's see Inmarsat. Inmarsat is a satellite phone service based on 3 geostationary satellites, and the major difference with Iridium comes from that. First, the fact that since launching 3 satellites is much cheaper than launching 66, Inmarsat can offer cheaper price points to their customers. However, just having 3 satellites compromises the global access, and in places like poles, there is no Inmarsat coverage. However, due to the fact that these satellites move slower and cover higher areas, they have not handover problems. Inmarsat is more reliable in the communication aspect, and especially in data connectivity. Since these satellites are very far away from the Earth, the lag on the communication and so the call quality is not good at all, needing big phones and big antennas to be able to connect. The aviation use of Iridium relies on the AMSS, Aeronautical Mobile Satellite Service, which is the service used for aerospace communications whenever no other service is available. So it is primarily used in oceanic and remote areas and in the poles. It allows the exchange of voice and data such as ATC, AOC, AAC, and APC, which are crucial sometimes for the airplanes. Iridium is a global phone satellite communication service, and so it is susceptible to the laws in the countries this operates. This is why, for example, in the US, the uplink communications band is limited to 1621.35 MHz to 1626.5 MHz instead of the 1616 to 1626.5 MHz of the global one. There are just 2 countries in the world that have forbidden Iridium to work in them. These are Sri Lanka and North Korea, for war reasons. The major problem with satellite communications is the price. Not just the price of the service, but also the price of the terminals. Nowadays, Iridium prepaid service costs around €2 the minute, and the terminal Iridium 9555 costs around €800, and the Iridium Extreme, which is the rugged solution, costs around €1,000. This might seem expensive, but however, in the launch of the service, these numbers were even higher. For example, on 1998, a minute of satellite communications costed around €5.5 and the terminals around €3,500. They were so high that the project crashed economically in less than a year. However, the project was not cancelled and is still developing. Nowadays, the phones are not the only products offered by Iridium. They also offer this, which is an Iridium Accent smartphone companion compatible with Android and iOS, as well as more specific solutions for boats such as this, and laptops such as this. The project is still under heavy development. getting ready to begin the launch in 2015 of the next generation of satellites that will improve overall, especially in the data networks and the speeds of transfer. However, in this generation, in order to save cost, the satellites will have an extra payload that is rented to the firms. In this case, Iridium Inc. is supposed to incorporate cameras on those satellites and use them also for surveillance purposes. As it can be seen, satellite communication are something relatively new that are still under heavy development, but that create a framework to the future where your positions will not be a problem to communicate with the rest of the world. And something is clear, and that's that Iridium will play a very important role in that future. This is it. If you have any doubt, feel free to leave a comment and I'll try to answer it as soon as possible. Hope you liked the video and see you in the next one.